So right now, we're not writing anything down. I have 3 shapes up there. And right now, you're just looking at what do you notice about the sides of these shapes. We don't have a pencil because we're not writing. Stop doing that. What do we notice? What's going on with the sides of these shapes? Madison, what's something that you notice? All the shapes have 4 sides. You are facing the wrong direction. Turn your entire body forward. Thank you. Macklin, what are you noticing about these sides? They are all straight. So if we've got 4 straight sides, do any of these shapes have holes? No. I see 4 corners. What could I call each of these shapes? What could be their name? If I wanted to name them, what could I call them? Carl? I could say every single shape up here is a quadrilateral because it has those rules. What else are we noticing about the sides? There's something else kind of special happening with our sides. Look carefully. Evelyn, what are you noticing? Okay, so we're noticing that some of them have equal length sides and some of them don't. Gia, what are you noticing? They do have opposite equal sides. That means the sides that are opposite are equal in length. Colby, what are you noticing?
So the rectangle doesn't have equal sides, but the other shape, not the square, doesn't have equal sides?
No, it does not.
Yeah, like the matrix that are like optical illusions and like that those shapes. Can you like if you draw a line, can you move it?
Yes.
Can you like trace how one of the short sides are and find it out to see if it's the same?
I could, but I picked a very specific shape, and that shape doesn't have equal sides. So I know for a fact it doesn't have equal sides. All right, so what we are going to be talking about today is we are going to be talking about pairs of sides or pairs of lines. When I say pairs of sides or pairs of lines, I'm talking about 2. So title, I know I'm going to write this underneath, which is a little funny, but your title is going to say pairs of opposite sides. You talked about this a little bit a second ago, and you're going to see this language, and it sounds really kind of confusing, but once we break it down, you'll be like, oh, I know what that is. Rylan, we should be writing right now. What does that word pairs mean? It's a homophone. There could be 2 different words. What version of pair am I talking about? What version of pair am I talking about? Am I talking about the fruit? No. No. Nope. I said the homophone. Bryson, what am I talking about?
Like pairs, like 2.
Yeah, like 2 things, like a pair of shoes. Right? Circle that word pairs. We're talking about groups of 2. When I say we're talking about pairs of lines, we're talking about 2. What about that word opposite? What do we know about that word opposite? Probably know a lot about that word opposite. What do we know about opposite? Mackenzie, what you know about opposite?
It's like different from that.
Okay, it's different. What else do we know about opposite? What else do we know about that word opposite? Ariana? Kinsey, what you know about that word opposite?
Up and down are opposite.
Okay. If I said someone is sitting opposite of you, what does that mean? They're sitting opposite of you. What does that mean? Kaden, what does that mean?
It's like the other way.
Okay. Okay. Ariana, you want to add on to that? They're sitting on the other side. Exactly. Exactly. I want you to draw a square as best you can in your notebook.
All right, I'm going to turn that off for just a little bit so I can find it.
Well, then can we reschedule this? Because I'm teaching from this. All right, so we've got our square. We're going to be talking about opposite lines. Specifically, top and bottom, just like what Mackenzie said, and then side and side. So I want you to draw a squiggle on your top line and your bottom line. Top and bottom. Well, this is the part where we're writing.
We're supposed to do scribble this.
Those lines are opposite. So far, so good. Let's do squiggle lines on the side and the side. Those lines, side and side, are opposite. So when we're talking about pairs of opposite sides, that's what we're talking about. Top and bottom, side and side. So far, so good. All right, I want you to look closely at our opposite lines. Something kind of interesting is happening with those sides. Specifically, they are this word that I would like you to write down. It can be a subtitle, it can be under your square if you want to. That word is parallel. Raise your hand if you've ever heard of the word parallel. Okay. We're going to talk about what that word parallel means. The word parallel, we're going to write what it means, and then we're going to kind of look at it. So to be parallel, that means that your opposite sides are the same distance away forever. Now that gets a little complicated, so we're going to explain what that means in a second, but I need you to write that down because it's going to help us when we're looking for parallel sides. Parallel means opposite sides are the same distance away forever. Go ahead and write that down in your notebook.
Something like endless.
Kind of. So a circle will not have any parallel sides. So again, it does not matter if my sides go diagonal, they can still be parallel. Just means that they're not going to run into each other even if those lines keep going forever and ever and ever.
What do the shapes below? Do these shapes have anything in common? In this lesson, you will learn to identify trapezoids and parallelograms by looking at their shared attributes. Let's review. We already know that quadrilateral has 4 sides. Let's sort these shapes into 2 categories. Shapes that are quadrilaterals and shapes that are not quadrilaterals. Which of these shapes on the left have 4 sides and can stay? This one. Which of these shapes on the right have 4 sides and need to move to the left? These two. So let's put these shapes in their correct places. Let's draw a line down the center. All the shapes on the left are quadrilaterals. All the shapes on the right are not. We are going to take a close look at 2 special quadrilaterals, trapezoid and parallelogram. A common misunderstanding is that trapezoids can only look like the outline of a lampshade. Let's take a look at trapezoid. I'm going to put 2 types of shapes up. The shapes on the left are all examples of trapezoids. The shapes on the right are not. Let's see if we can find or identify which attributes the shapes have in common so that we can make a rule for trapezoids. I want to look at the shapes that are not trapezoids to help me. First, I'm going to look at this shape with a curved bottom. None of the trapezoids have any curved sides, so trapezoid must be a polygon, a shape with only straight sides. Now, I'm going to look at this shape with an open corner. None of the trapezoids have open corners, so a trapezoid must be a closed shape, which is another attribute or rule for a polygon. On the right, I see this shape with 3 sides called a triangle. It does not seem that there are any 3-sided shapes that are trapezoids. All of the trapezoids have 4 sides, and I know that 4-sided shapes are polygons, called quadrilaterals. So the first part of the rule, trapezoids must be quadrilaterals. Now I have one last shape, and this shape has 4 straight sides that meet at 4 corners, which also makes it a quadrilateral. But it is not considered a trapezoid. We need to figure out which attribute makes this quadrilateral different from the trapezoid. Let's take a closer look at these shapes. What do all of these shapes have in common? All of these shapes have 1 pair of parallel sides as an attribute. That means they have at least 1 pair of sides that are opposite from each other, that run in the same direction, and are the same distance apart from each other. How do I know if a shape has parallel sides? I pick 2 sides that are opposite from each other, like this top side and bottom side.
We did that.
If I were to measure the distance between each of these sides with a ruler or with a piece of paper, no matter where I put the ruler or the paper, the 2 sides will always be the same distance apart. Here's my slip of paper. I will mark the distance between my 2 opposite sides here and here. No matter where I move my paper, the distance apart stays the same.
It's pretty cool.
These opposite sides are the same distance that makes them parallel. What about my right and left sides? Here's my slip of paper again. I will mark the distance here and here. If I move my paper, I will notice that my line does not match.
Same measurement.
So, they are not parallel. These opposite sides are not the same distance apart. Let's revisit our groups. We know that trapezoids are quadrilaterals. Does this shape on the right have parallel sides?
Oh. Any parallel sides?
No, it does not. Now we know trapezoids are quadrilaterals that must have 1 pair of parallel sides. Take a look at these shapes. What do all of these shapes have in common? If we look at the number of sides, all of these shapes have 4 sides, which means they are examples of quadrilaterals. What else do we notice? These shapes also have pairs of opposite sides that are the same distance apart. All of these shapes have parallel sides. But look closely. These shapes do not have just 1 pair of sides that are parallel. They have 2. And because these shapes have 2 pairs of parallel sides, they are called parallelograms. In this
Title, again, is a special quadrilateral, a parallelogram. So we already know what a quadrilateral is. We already know that. We've seen lots of shapes that are quadrilaterals. But not every quadrilateral is going to be a parallelogram. There are some special ones that get to be called both of those names. So, let's revisit our rules for our quadrilateral. In order to be a quadrilateral, we have to have 4 straight sides. We have to have 4 corners, also known as angles. And we have to be a closed shape, aka a polygon. I'll give you some seconds to get caught up. I know that was a lot of writing. A parallelogram has all of these things. And two pairs. Sometimes you'll see the words sets. It's not going to be like that. Of parallel sides. Two, yes, it's an L, parallel. Two sets of parallel.
Two L's right there, parallel.
Yes. So we'll have some shapes that can be called only quadrilateral. That's it. And then some of those shapes can be called quadrilateral and parallelogram. Special shapes that have that double name. We're going to talk about, there's lots of overlaps, but right now we're just talking about parallelograms. I need you to get out a pair of scissors and a glue stick. We're going to look at some shapes that are just quadrilaterals, and some that are both quadrilaterals and parallelograms, and some that are neither of those things. All right, find group A. Find group A. With your 2 colors, I want you to find the opposite sides and squiggle them, just like we practiced a second ago. I want you to do that for every shape in group A. That's not what I said. I said you're going to do the opposite sides. You're going to squiggle them so you know what is opposite for every shape in group A. So for instance, see, I might have red and do my top and my bottom. Those are opposites. And then with my other color, I'll do my side and my sides. You're going to do that for every shape in group A. Every shape will be colored with the top and the bottom so we can easily see those opposite sides. Jalen, you've done that? For every shape in group A? Okay. All right, so let's put our hands on the top and bottom. Grabby chop them, top and bottom. Are the top and bottom lines parallel?
Yes.
Yes, with your pencil, you're going to put check marks. Check, check. Those 2 lines are parallel. They're not going to run into each other. What about the sides?
No. Yes.
Put your hands on it. If they keep going, are they going to run into each other? Yes or no?
No.
If they keep going, are they going to run into each other?
Yes.
Yes, so they are not parallel. We're going to put X's. Does that make sense what we're doing? Yes? No. Do that for the rest of the shapes in group A, please. Put checks if they are parallel, meaning they're not going to run into each other. Put X's if they are not parallel.
Both of them should be parallel shape.
Of the shapes in group A should have had 2 check marks per shape. 2 check marks per shape, meaning that there is one pair. This one and this one. So far, so good. Show me with your arms. Look at shape number 7. Make your arms the parallel sides. Show me in the air. What do the arms look like? The parallel sides were not going up and down on this shape. Nope. The parallel sides are not going up and down on this shape. No. Jalen, those are not parallel. They will run into each other. No, those are going to run into each other. The parallel sides on shape number 7 are the top line and the bottom line. So with your hands, you should be showing me top and bottom. All right, let's look at shape number 10. Show me with your arms. Where are the parallel sides? Show me with your arms. Where are the parallel sides?
Possible for the top side to be parallel, not parallel.
Remember, parallel means they will never, ever, ever, ever run into each other. Yep, it's our top and our bottom. Right here and right here. Shape number 9. Show me the parallel sides with your arms. They are never, ever going to run into each other. It is side and side. These lines, if they kept going forever and ever, would never touch. They're the same distance apart. What about shape number 3? Show me with your arms. Where are the parallel sides? Ooh, is it side to side or up and down? It is up and down. Those should have check marks. The other ones should have X's. They will.
If you keep going.
If you keep going, they will
But it just gets farther away.
go the other direction. Because it shouldn't get farther away either, because remember, parallel means they're the same distance. It should stay the same the whole time. All right, we're going to do the exact same thing for group B. You're going to do the exact same thing for group B. First, find your opposite pairs with your crayon. With your crayons, find your opposite pairs. And then checks if they're parallel, X's if they're not parallel. All right, let's look at shape 2. Look at shape 2. Did shape 2 have parallel sides? Yes or no?
Yes.
Yes. Show me with your arms. Where were some parallel sides on shape 2? All right, I see some tops and bottoms. Are top and bottom parallel? Yes, that is true. I see some diagonals. I saw some diagonal hands like this. Are the diagonals also parallel?
Yes.
Yes, so you should have check, 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 check. We have 2 pairs. This set is parallel and this set is parallel. So I can call that shape a quadrilateral. I could also call that shape a parallelogram because it's got those 2 sets. Look at shape 6. Show me with your arms where are the parallel sides. All right, we've got, I see tops and bottoms. That's parallel. And I see side to side. Can I call that shape a quadrilateral?
Yes.
Yes. Can I call that shape a parallelogram?
Yes.
Yes. What about shape 12?
And you can call it
We're going to talk about that. Save that thought, Zach. What about shape 12? Where are the parallel sides on shape 12? There's definitely parallel sides up and down. Right here and right here. Those are definitely parallel. And then our diagonals, they will never ever touch. They're going to stay the same distance apart. I'm going to keep going. So I had 2 sets of parallel sides. What about shape 8? Show me your hands. Good at parallel sides?
Yes. Square.
Yes, a square. Also known as a. Also known as a. It is not a trapezoid. We're going to talk about trapezoids tomorrow, but a trapezoid only has one pair. This one has two pairs, so it's not a trapezoid. It's not one or more. It's one only. Colby. Okay, Saturday, or on Monday. You know what I mean. We've been in school long enough to figure it out. What about shape 4? Show me with your arms. Where are the parallel sides? You should have two. You should have a top and a bottom. And a side and a side. All right. With your pencil, we're going to label group B. What can I call every single shape in group B? What could I name them? This is the part where you're raising your hand. Huxley? I can say these are all quadrilaterals. I'm writing, you're writing with pencil, please. Quadrilaterals. There is a more specific name, a better name. What else could I call every single shape in group B that's slightly better than quadrilateral, more specific? Gio? A parallelogram. There's a clue word in parallelogram to help you remember. Parallel. So if you're trying to remember, what's a parallelogram? You should probably remember it's got parallel sides. Specifically 2 sets of parallel sides. Let's go down to our shapes that don't belong. Why do those shapes not belong? They don't belong in either of our groups. Why not? What's going on with those shapes? You might have to look at them to figure that out. Why do those shapes not belong? Don't do that. Zach?
Because all sides touch.
Well, all sides touch on my other ones. John?
Maybe it's like each of these are certain groups of something.
They are certain groups, yep.
And then these two don't belong. Maybe I said no top and bottom are yeah, that one has no top and bottom because that is the top right there. That's the bottom.
Let's look at shape 11. Look at shape 11. I do see parallel sides on shape 11. Do you? So why does shape 11 not belong? We've been counting parallel sides. Why would that not belong? Heidi?
Because it has 5 sides.
What do we call a shape with 5 sides? We wrote it in our notebooks. Yes, ma'am, Madison. Way to go back and look for it. You either are raising your hand because you know it, or Sam, or you're looking back in your notebook and figuring it out and then raising your hand. This is not the time to share these thoughts out loud, Rylan.
Oh, I have a question.
You could have watched these at your house. I sent them to your mother. Kinsey. Pentagon. This is not going to be a quadrilateral because it is called a pentagon. I'm writing, you're writing. So it can't be a quadrilateral, which means it can't be a parallelogram. It doesn't belong in any of those categories. So wait, count the sides on shape 5. Is it a quadrilateral? Yes. So why doesn't it belong with my other quadrilaterals? What's wrong with it? It's got 4 sides like all my other shapes. Why doesn't it go with any of my other groups? Macklin? There are no parallel sides. So we're going to write 0 parallel sides. Yes, that shape is a quadrilateral, but it is not a parallelogram because it has 0 parallel sides.
Can you show us why?
I just told you why.